Yes. Good afternoon to one and all. Hope my slides are visible.
Yes, sir.
Yes. What was the answer for the problem 11?
X1 equal to minus 0.854.
Little louder.
X1 equal to minus 0.854.
Just a
X2
minute. I'll write it so that your friends can recognize. X1 is
minus
minus
0.854.
8654.
854. Sir, not a 6.
854.
Yes, sir.
Okay. Okay, 854 and x2 is equal to
The minus. You forget minus.
minus. Okay, x2 is equal to
2.236.
2.236.
Yes, sir.
Okay, x3 is equal to
2.03.
2.03.
3
Okay, x4
minus 0.
just a minute. Minus
936.
0.936.
Yes, sir.
Yes, yes. Hope you all solved this Thomas algorithm problem. I think there won't be any doubts with these Thomas algorithm. Now we'll begin the classes with the
Excuse me, sir.
iterative methods.
Excuse
So
me, sir.
far, we were discussed. For me, you please confirm whether we started. I think started the recording, right?
Yes, sir, we started the
For
recording.
me,
So.
you.
Yes,
Yes,
sir, we
yes.
started the recording.
Excuse me, sir.
Just a minute. I think my sounds are
Excuse me, sir. Doubts.
so minimal. Just a minute. Just a minute. I'll. Yes. Yes, tell me, what was the doubt?
So in the previous question, I'm getting x like all four values one, sir. X1, x2, x3, x4.
Which problem?
So example 11, sir.
Example 11, all x are 1?
Yes, sir.
No. Now, see, I think Anshu revealed the answer. You joined late, ah?
So no, sir. I like if we check also, it's coming like that, sir.
Any other answer? I think, yes. Is Vignesh telling that the all the x's are equal to 1, but Anshu sharing different answer. Any other different opinion?
Sir, I also got all the answers of one, sir.
One, Sabarish.
Sir.
Okay, then
Sir, maybe uh, they take -1 in upper.
wait, just a minute. I'll get. What was the terms in the super diagonal matrix? Sabarish and Vignesh, have we considered 333?
333, sir. I took 333.
Yes, sir.
Take a photograph and
Yes.
post it in the group so that Anshu, you also you take a photograph and send, and I'll evaluate and I'll tell you which one is right.
Yeah, okay, sir.
Okay, concerning today's class, we request a few people to join with us till the end. From 101. 101, Siddharthan. I think
Yes, sir.
Siddharthan. Okay. 3 raised T. 106
Yes, sir.
and 109. Tarun. Tejawat Tarun. 111. Tushant and 113. 113.
Yes, sir.
August. August. Yes. Yes, you join till the end.
Yes, sir.
Yes, okay. Yes, this is what we were seen during the past classes. That is direct methods. We were solve the problem, but there are some other techniques is also available to get the solution for system of linear set of system of equations. And uh, concerning to our syllabus, we are going to deal with three different titles: Gauss-Seidel, Gauss-Jacobi, and SOR method. We'll crack one by one. See, the iterative method, the elimination methods, whether it might be Gauss elimination or other Gauss-Jordan method, these procedure are often called direct evaluation, direct equation solving methods. But an iterative method is a trial and error procedure. What we are going to do, we are going to assume one set of assumptions, and based on the assumption, we are going to move ahead towards getting solution. Our ultimate objective is to get the solution, but that too with accurate solution. But we are going to take a path, we are going to take move from the assumptions. In iterative methods, we can assume a solution, that is a set of estimates for the unknowns, and successively we are going to refine our estimation of the solution through some set of rules. And the major advantage of iterative methods is that they can be used to solve the nonlinear simultaneous equations, a task that is not possible using direct elimination method. So by this way, we can categorize these iterative methods and the direct methods. So when we are dealing with the linear simultaneous equation, that can be possible with the aid of direct methods, and when we are dealing with the non-linear simultaneous equation, that can be possible by the iterative methods. This was the second of unit 2, and we were already completed the first half. And in the forward elimination, what we were converted the entire given set of equations into matrix form, and the matrix with the matrix form we were trying to find the results by the application of either it might be a forward elimination or it might be a backward substitutions. And these are the basic informations or notations in the iterative methods. Once we are familiar with the problem, at that time we will again we will come to this slide and we will discuss about these terminologies quite sometime later, and we'll begin the problem. In this title, we are going to introduce the Gauss-Jacobi method first, and then Gauss-Seidel method second, and then this is what the various phenomena. But once we are familiar with the problem, that then it will be easy to understand the terminologies. So we'll crack the problem first. You please make a note, that is, solve the following equations using Jacobi iteration method. This is what the problem. 20x plus y minus 2z is equal to 17. 3x plus 20y minus z is equal to minus 18. 2x minus 3y plus 20z is equal to 25. Yes, here the major constraint in the Jacobi or Gauss-Seidel method is your diagonal should be dominant. Your diagonal term should be dominant. If it is not, you please rearrange your equation in such a way that you'll get the results. And in such a way that the diagonal terms are dominant. See here, when I am trying to keep this as an matrix, What would be the diagonal? 20, 20, 20 would be the diagonal. These diagonal terms should be the dominant terms than the other terms. Accordingly, you if it is not, accordingly you rearrange your given equations. So here no need to go with matrix. Will solve this system of linear equations with Jacobi iteration method. What I am trying to do, I have this has to be the first equations. From the first equation, I am keeping the x alone in the LHS, and I am trying to make the other terms in the RHS, that is 17 minus y plus 2z. And similarly, in the second equation, I am keeping the y alone in the LHS term, and therefore minus 18 minus 3x plus plus z would be the second equations. And the third equations will be 20z is equal to 25 minus 2x plus 3y. Is it right? So we are going to do iterations. For doing iterations, again I am concerning about where is x, y, z, but here we have the x, y, z with a coefficient. Therefore, the coefficient has to be sent on the other side. So my newer system of equations would be x is equal to 1 by 20 into the various other terms. Similarly, my y and z. Okay. For in order to do the iterations, we have to have some certain assumptions. And therefore, my assumptions would be x, y, z is equal to 0 in the first approximation. You can begin with various other parameters also. That won't be an issue. Definitely, the taking the initial assumptions won't influence over the results. It has a self corrections. By doing solutions, it automatically it will self correct. So there won't be any issue with the initial assumptions, but we will begin with zeros. That is x naught is equal to 0, y naught is equal to 0, and my z naught is equal to 0. Here, now to represent the first approximation, I have denoted as x1, y1, z1. The earlier assumptions, let it be y naught is z naught. Therefore, let x naught is equal to 0. This is what my assumption. Y naught is equal to 0. My z naught is equal to 0. See here how the matrix calculations. I'll tell you. You take your calculator with a easier way. You can do the calculations. See here. This is what you please take your calculator.
So can you turn off screen share?
Yes, I am going to showcase the operations through calculator, so it is essential. Siddharth, and 113. Yes, Siddharth, Sri Rishti.
Yes, sir.
Yes. Are you with us?
Yes.
Yes. You take your calculator. You please take your calculator and do the procedure which we are trying to disseminate. See, my coefficient is in all the equations. My coefficient is 20. Is it right? In which way we can reduce the human effort? Right. I'll tell you whether my calculator is visible.
Yes, sir.
Here what you need to type give open bracket 1 by 20, because my all three equations has a coefficient as 1 by 20. Therefore, I have given as 20. Then start with a. Give recall a. Then you will get a. Then plus recall b, recall c. See here. Recall B and recall C, and again plus recall D and recall E. Yes. This is the way that you can reduce the human effort, because we are going to do a repeated task. For now to reduce the various repeated routine work, we can reduce by way of giving these equations in the calculator. What I have given, I have started with the open bracket 1 divided by 20 into A plus BC plus DE. What you need to do here, there is an option called CALC. Give with CALC, that will seek the value of A. My A is, see what my here, my A is, this is what my A, 17. Okay, give 17 and give equal to. Then my B is the coefficient with this particular term is my B. In that equation, in the equation which was fed in the calculator, I have given all positive. Here A, just a minute. This is what A plus B into C. The coefficient is denoted with B, and the term Y naught is C, plus my coefficient here is D, and Z would be D. This is what we were given in the calculator. So therefore my B is -1. -1, and my C here, my C is Y naught. My Y naught is I have considered the Y naught is 0. Therefore give 0 and then equal to. It seeks about D. My D is 2. Right, and then it again seeks about E. My E is my Z naught. Here Z naught is also 0. Then you will get the answer. Therefore my x1 is equal to 0.8. By continuing this one, we will get again. It will ask about A. Now my A is I am at present I am interested towards knowing the value of y1. Therefore this is what my A, -18 give equal to. Here my coefficient is -3 give equal to. My x0 is equal to 0, give 0 and equal to, plus my D is 1, give equal to, and then it seeks about E. My E is my Z0 is also 0. Then you will get the answer for y1. My y1 is equal to -0.9. Similarly, you calculate the value of Z1 and tell me the answers. Whether it is clear? A plus BC plus D. Yes. Z1 is equal to 1.25. Okay, don't clear the given equations, because it is essential for continuing the problem. This is what my first approximation. What we can do, we can continue the problem with the second approximation. These values has to be carried out to find the results in the subsequent iteration. That is what about the second approximation or second iteration. And for second, in order to describe about the second equation, let the LHS would be 2 with suffix, that is x2, y2, and z2, and the RHS suffix should be 1, that is y1, z1, and etc. And now my inputs are 0.85 minus 0.9, 1.25. Is it right? So by applying the first approximation values, you'll get the x2 value. Siddharthan, you please share your screen and tell me repeat the procedure which I have disseminated. Siddharthan.
So I don't have that calculator.
You don't have. See, we were. This is what our 5th class. Then when you'll buy the calculator? When you'll arrange the calculator?
Not available, sir.
At present, you see, you are for 3 classes. We have very limited classes. You arrange the calculator.
Okay, sir. Sorry for.
No issues, no issues. And 3D 106.
Yes, sir.
Yes. you share the screen and show exhibit your calculator and try to find the second approximation results.
Okay.
Is go fast. Already the time is 12:55. What happened? Okay, you prepare for the third iteration. I'll tell you. Yes. Yes, you prepare for the third iteration. I'll tell you the second iteration. You tell me the answers for the third iteration. Yes, again I am telling. Yes, my now I need to find the values of now I need to find the values of my x2. My x2 here it's 6 for a. My a is my 17. Give 17 and then equal to, and then bc. My b is the coefficient of y1. Here minus 1 is equal to, what is my y1? My y1 is already calculated, that is minus 0.9, then give equal to. Then it's 6 about d. My d is 2. And then give z, give the value of it's 6 about the e value. My e is my z1. Z1 is 1.25. Therefore, the results are 1.02. Similarly, do the subsequent steps now to find the y2 and z2. My y2 is minus 18. Again, give equal to minus 3. My it's 6 about my x1 0.85, and then it's 6 about the coefficient of z1 1, and then z1 value is 1.25. You'll get the answer is minus 0.965. And then similarly, by giving 25 minus 2, 0.853 and minus 0.9, you'll get the z value as 1.03. Okay. Okay, this is what the information from the second iteration. Now we will find the values for third approximation. Yes, go ahead, Sri Dristy.
Excuse me, sir.
So I'm
Yes,
getting
Vignesh.
Z3 as
So
1.
Z1, I'm getting 1.3, sir.
Z1.
Z2, sir, sorry. Z2, sir, sorry.
1.353. Z2.
1 point, just a minute. I'll cross check and let you know. No, it is not the case. Minus 0.965. You please cross check.
So Z2, sir.
Z2 is
1.3, sir.
1 point,
3, sir.
353.
1.353. No. 1 point is 1.03.
So I'm getting 1.03, so
No. Yes, it is 1.03.
Okay, sir.
That is what my concern. When we are trying to solve the problem, there the problem exists. That is why I have disseminated how we
So it's
can get
1.03,
the
sir.
solution. Yes, Sriristi. You can find the results for third approximation.
Please, I'm solving it, sir.
Yes. You share your screen and tell me the procedure which I have disseminated.
Sir, so the equations will be x3 is 1 by 20 into 17 minus y2 plus 2z2, and similarly y3 and z3 also, sir. Then
Yes, you can without the equations also you can find, but it will take time. Okay, anyway, you tell me the results for third approximation.
Yes, sir, 1 second, sir. Just solving.
When you fed, which I have said, it will give you the data as in a second.
Sir, X3 is 1.001.
Okay, before that you fix your calculate digit into 3. Before that you do the mode change and fix the 3-digit accuracy, and your X3 is equal to 1.001.
Yes,
And
sir.
what is your Y3?
Yes, sir, 1 second, sir.
I think you are typing now. You are typing 1/20 into -18 -3 into something plus. That won't be essential. That is what I have.
So in the 3 equations, I put the coefficients of 3 and get the answer.
Yes, yes. That is also feasible. Even these 20, we don't have uniform coefficients also, we can do with the aid of calculator. But the thing is, we need to include instead 20, we need to include any other terminology. That's all. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 different terminologies we can introduce in the calculator from A to M. A, B, C, D, E, F, X, Y, and M. If it is the coefficient is not 20, here 20, let it be here 30 and 40. What we are going to do, we are going to introduce one more constant here. One by, let it be 1 by A, and then B plus CD plus EF.
Sir,
That's
Y3 is also minus 1.0015.
no, it is minus 1.002.
Yes.
Okay, what is your is that 3?
That is 1 second. So Z3 is 1.003.
1.003. Yes. Okay. Concerning fourth approximation, triple one. Tushant, Tushant, you tell me. Yes, tell me the fourth approximation results, Tushant.
What's that?
Tell me the results for fourth approximation.
1 second, sir.
Please.
Sir, x4 is equals to 1, sir.
1. Okay, good. Then Y4.
1 second, sir. Sir, y4 minus 1, sir.
-1. Good. Then
Sir,
Z4.
1 second, sir. Sir, z4 is also 1, sir.
Z4 is also 1. Therefore, our solution should be x4 is equal to 1, x is equal to 4, y4 is equal to y is equal to -1, and z is equal to 1. And this is what about the iterative method, that is Gauss-Jacobi iterative method. So what we will do here, we will try to find the results with the aid of Excel. Uh, uh, may I know those who have the calculator, you please raise your hand. Those who are listening the classes through laptop, you please raise your hand. Is Vignesh, then Anshu, Sridristi, Siddharthan, then others you please. Is very good, very good. Well, Vijay, Gogul, Sanjay, Sabrish. He is very good. We will do one thing. We'll do these calculations. Whether it is interesting to get the solutions via Excel, isn't it?
Yes, sir.
Yes. Okay. We'll find the result. See, this is what the earlier we made during the past class. That is in the last class. Here now, parallelly you do you work with your laptop. I'm taking a new sheet. What I am trying to do, this is my x datas and y and z, and I have some constant on the RHS. Okay, now tell me the and make it as center alignment. Okay, what are the coefficients? 20. Tell me the coefficients. Someone, you please tell me the coefficients. 20.
1 and -2.
1 -2. The constant RHS.
17.
17, sir.
Okay. Then in the second equation,
3, 20 and -1.
320 -1 RHS
-18.
-18. Okay, third equation,
2 -3, 20.
minus
3. 20.
Then 20.
20.
My RHS is 25. Okay. See now what we are going to do. I am making as this as iteration. My x, my y, and my z. I am making this into center element, and the first iteration should be in the left. Okay, now I am feeding 1, 2, and 3. What we need to do here, you drag with this corner. See what was done here. It continues, isn't it? If it is 1, 2, 3, it continues with 4, 5, 6. Like if it is 2, 4, 6, then see, in a fashion which we are giving in the same way, it continuing the process, isn't it?
So is the
Let it
column
be
X, Y, Z, sir?
X, Y, Z, sorry, X, Y, Z. Okay. Okay, I'm making the first column also as center. Okay, now we'll find the values with the yes, I'm making one more row here. This is what my initial assumption, that is 0, 0, 0. Right. Now we'll find the values of the first iteration. Okay, here what we need to do, someone tell me. You are already aware about yesterday itself. I have disseminated some basic calculations with the aid of the Excel.
Equal to
Yes, equal to. Okay. Then
1 by d.
I am making an open bracket. 1 divided by, very good. 1 divided by
d2.
CC2.
That
Very
is
good,
equal
very
to
good. Very good, very good. In C2. Okay, not C2. This is what G2. G2. Right? No. Okay, we will take
D2.
just a minute, just a minute. We'll take this that. Okay. This is
1
what we
divided
need.
by D2.
Okay. This is what we need. Okay. Now tell me. Is
1
equal
divided
to
by D2.
equal to is making open bracket 1 divided by here my 20. My 20 is the coefficient which is associated with this x, right? Yes. You keep your cursor in D2 or either you type D2 close bracket and open bracket, then 17 that is G2 minus my coefficient y coefficient see here minus no I am making this as plus and see while changing to RHS it makes minus into y, right?
Yes, sir.
Minus this one, right? Plus and then my what my coefficient, sorry, before that my coefficient is 1 and with that we need to include my y value, isn't it? This is what my y value, close the
See, sir.
bracket, plus my 2, where is my 2? This is what my 2. Here I have given a positive value. When it is converted into on that side, it will be taken as negative. Therefore, I have introduced negative for E2 and F2. E and F. Right, into what is my Z? This is what my Z. Okay, now give close bracket and again bracket. Okay, yes, this is what your X1, right? Okay, whether it is understood or shall I repeat? Shall I repeat? Okay. In the same way, someone you please tell me how we can find the value of y. Someone, my already 110. The time is 110. Please tell me how we can get the values of y. Bracket 1 divided by 1
divided by E3.
1 divided by
E3, sir.
E3. Yes, of course. Very good. Then I am making open bracket. And this is already in RHS. No need to include the negative symbol. And plus here I am making minus this term into my x. See here I have given x in this B7 and close bracket again plus open bracket and the coefficient is z. So referring with these equations I am giving my z, where is my z? Minus of my z into my this is what the coefficient but I am concerned about ez. This is what my ez, close bracket. Okay, and again here I have started with a bracket, so I am closing. Yes, we found a typo in your formula and tried to correct it too. Do you want to accept this correction? Yes, yes, it has to be corrected. Give yes, yes. See, this what are y1. Okay, okay. Tell me how we can find the value of z.
So 1 by F4.
1 by tell me 1 by f4. Then tell me. Go ahead.
Into G4.
Into yes, g4.
Bracket minus 2
Plus open
minus
bracket
D4.
minus
D4
yes, d4 into
into B6.
your x.
B7.
X.
B7. B7.
Yes, yes, very good. Plus open bracket negative then
Negative E4. E4 into
e into
C7.
z. Very good. That's all. That's all. Yes, this is what 1.25. And by doing drag and drop, whether we can find the results of other iteration, whether it is feasible.
Yes, sir.
Yes, but minor changes has to be done. See here, I am doing for only one. What happened? What is my what is our x2? What is our x2? Tell me what is our x2 during mathematical calculations, manual calculation. Refer your notebook and tell me what is our x2.
1.02.
1.0.
Yes, but it seems it returns minus 1.416. Why? Why? Yes, see here I am making double click. What happened? It has to refer the first equations, right? It has to refer the first equations, and taking these values are right. Taking the iteration values from the 8th row is right, but it has to take the values from the first row itself, right? Then what we need to do? See here, I am getting this is what my A, and this is what my B. And during just a minute. What I am trying to do, I am going to drag and drop. See, this is what taking from the past. I am giving the H14 while doing drag and drop. What it does, and it make the changes from the cell itself. From where we were taken the calculation, here it was given as H14, and now it was converted into H15. Here now it was converted into 16. But my concern is it has to take from a constant the data has to be taken from the constant cell, right? These data has to be taken from the constant cell. This has to be constant. Only this term has to be changed. And what we need to do in order to take constant cell, my concern, I need to take this one for my further calculation, this value. I need to take this H14 alone. Even my drag and drop also, I need to take this H14 alone. What we need to do? There is an option called dollar symbol. When you are applying the dollar symbol, what it does, it make the row as constant. See here, I am doing drag and drop, it taking the same row. So in order to make the row constant, introduce a dollar symbol before the row, and in order to make the column is constant, and introduce the dollar symbol before the column. Right, it is understood. That it is clear.
Yes, sir.
Yes. Here my D2, I am concerning about D2. My D2 is D2 has to be taken from the D2 alone. Therefore, I am introducing a column dollar symbol before D and before 2. And G, yes, G also constant. My E2 is constant. 2, wherever I have 2, that is constant. C7 has to be updated in every iteration. And F has to be taken 2. F has to be a constant. Yes. In the same fashion, I am concerning about 3. Wherever I am having 3, I am introducing a dollar symbol. Yes. Now for equation 3. Right. What we can do now, by doing drag and drop, I can get the accurate results, right? This is what the results. This is what the results from. This is what the results. Where compare with the manual calculations, whether it is right.
Yes, sir.
Yes. Okay. Now, in order to keep a cell as a constant, what was the symbol we were used?
Dollar, sir.
Yes.
Dollars.
The dollar has to be introduced if you want to make the column as constant, introduce before a column. If you want to make the row as constant, introduce the dollar symbol before row. If you want to restrict a cell, introduce dollar symbol on both before row and column. Here we were concerned about the cell. Therefore, I have introduced dollar symbol on both row and column. So this is what the Gauss-Seidel method. Sorry, Gauss-Jacobi. I am rename Jacobi method. Jacobi's iteration method. Whether it is clear? Okay, now tell me the first problem, whether it is working or not. We'll check. The results of first problem. Sorry, the coefficients of first problem. Tell me the coefficients of first problem. What happened? Vignesh. Vignesh.
So yes, sir.
Yes, tell me coefficients of the first problem, Vignesh.
So which part, sir?
Example 1. Hope you have built your equations. You cross check whether it is working or not with your data.
Yes, sir.
Now tell me. Yes, now tell me. Tell me.
Sir, I'm doing the Excel right now, sir. I've not completed it, sir.
No. You refer the first problem and tell me the results. Tell me the coefficients. We will check whether it is this as right or not.
Yes, sir.
Sir,
Sir,
Yes.
so how can we round off, sir? Like in calculator, you said, sir, like we can do fix 3.
Yes. About it. Sanjay, very good, Sanjay. Yes. I am showing now. I am showing. See here, I have I have selected a particular cells and go here. Here there are two different options, and by doing this way you can make it as 3. I have rounded it into 3, right? This has to be 4, 5. Where we can find this, you click a small arrow mark and you'll get number, and whichever decimal is essential you put here, whether it might be a 3 or 4, so that we can round off in the Excel too. Very good, very good, very good, Sanjay. This is what essential, the interactions and knowing. And I think still, Sanjay, you tell me the first problem coefficients. This is what our problem. 1, minus 1, 1, 1. 1. No, this. Tell me 1, minus 1, 1, and 1. Then the second equation.
minus 3,
Yes. Minus 3,
2,
minus 3, 2,
minus 3,
minus 3,
minus 6,
minus 3, and minus 6. And here
2,
2,
minus 5,
minus 5,
4,
4,
5.
5. What was the results there? Minus 2, 3, 6. What happened here? We'll do some more iterations. And 1, minus 1, 1, 1, minus 3, 2, minus 3, minus 6, 2, minus 5, 4, and 5. Okay, you refer with these various examples with your Excel and let me know whether Excel is working or not. Okay. Okay, you please share your screen and introduce about yourself. Already it is 1:25. The first fellow. Siddharthan. Siddharthan, introduce about yourself, Siddharthan.
So I am Siddharthan from Trichy, Tamil Nadu. So can you hear me?
Yes, yes, yes. Go ahead, Siddharthan.
So my father is inspector of police, and my mother is a homemaker.
Where you did your schooling?
So Montfort School near Kato.
Just a minute. Okay. You put. Yes, Siddharthan. Siddharthan, you are staying in Katur.
Yes, sir.
Yes. You did your schooling. In which station your father is working?
So near NIT.
Near NIT Tuakudi.
Yes, sir.
Inspector of Police.
Yes, sir.
Very good, very good. Very good. When there is an issue, we will make a call to Siddharthan. Okay. Yes. 3D 106. 106.
Yes, sir.
Yes.
Yes, sir, I'm Srishti from Chennai.
Yes. Still. Okay.
So I'm Srishti from Chennai. And my dad works in airport. My mother is a teacher.
Your father is a
My dad works in airport.
airport. Good. Your mother is a
She's a teacher.
very good. Very good. Fine. Fine. 109. One on three. Tushant. 1 on 3.
Yes, sir. Tushant. Tushant.
Yes, Tushant. Tushant, am I right?
Yes, sir.
Yes, Tushant. Go ahead.
I am Tushant. I am from Madurai.
Yes. Share your screen, Tushant. Yes, you're from Madurai.
Yes, sir.
What was your mother tongue?
Sir, I can hear you.
What was your mother tongue, Tushant?
Tamil, sir.
என்னப்பா தம்பி துஷாந்த்னா என்னப்பா?
சார் எனக்கும் தெரியாது சார்.
சரி கேட்டு சொல்லுங்க. அப்பாட்ட அம்மாட்ட
ஓகே.
யார் பேர் வச்சாங்களோ அவங்கள்ட்ட கேட்டு சொல்லுங்க.
ஓகே.
It seems a name depicts North geography. Okay, fine. What is your father and mother?
Father name is Mahesh, sir. Mahesh, and he is a ICICI agent, sir.
Okay, he's working in ICICI. Okay,
Yes, sir.
mother?
Mother is a homemaker, sir.
Okay, good, Tushant. At present, you are in Madurai.
Yes, sir.
Very good.
Thanks.
Okay. Is last 113? 113.
Good morning. Good afternoon, sir.
Yes, Nagasri.
Good afternoon, sir. I'm Nagasri from Telangana. My
Yes.
father name is Bhaskar. He is self-employed. My mother name is Aparna. She is homemaker.
What is your father? Vanam Nagasri.
Tyler, sir.
Pilot.
Tyler, sir.
Tyler. What was your mother?
Homemaker, sir.
Very good. Very good. Okay, Nagasri. Do well. Okay, we'll meet tomorrow. Not tomorrow, and we'll meet Monday during 10:30. We'll meet. Thank you.
Thank you, sir.